Welcome everyone to Algebra 2, Section 8.2, defining general angle measures, or angles, and using radian measure. So, we're going to, this isn't going to be warm, we're just going to go through notes together here. You are going to know some of these, but others you just won't know. So, a blank is determined, or a or an blank is determined by rotating a ray around about its vertex. That's an angle. The starting position of the ray is the initial side. Might be able to figure out the other one now, of the angle, and the position after the rotation is called the terminal side. So initial means the starting and terminal means it's the ending. In standard position, the initial side of an angle coincides with the positive side of the x-axis, meaning as long as it's in standard position, the initial side is always the x-axis and the positive part of it. Angles that have the same initial and terminal sides are what we call coterminal. The two ways to measure angles are degrees, and our new one is going to be radians. And then positive angles are generated by a counterclockwise rotation. Meaning negative angles are generated or created by a clockwise rotation. So sketch an angle in standard position with the given measure. So standard position means it's starting on the positive side of the x-axis, so right over here. 120 degrees positive, so it goes counterclockwise. And this would be to 90, so we go 30 degrees more, and we go to right about here. And it's good to draw a line and say, hey, it ends there, and that is going to be an angle, and to note that, hey, that's 120 degrees by writing it. Now our 560 degrees, well, one full way around would be 360, so we got to go another 200. So that would be 90, another 90 up to 360 plus, one full way around would have been 360 up, so 200 more. This is 180 more now with that 1/2 rotation. So we need 20 more degrees, so we'll go right there. And we'll say it is now 20 degrees from this axis, okay? So we went 120 degrees from this axis, and really I should probably be putting 60 degrees from that axis. We haven't talked about it too much yet of why we're doing that, but it's I'll tell you the brief part of it is always in reference to how far it is from the x-axis. So this is 60 degrees from the x-axis, which makes it 120 degrees from that side. This is 20 degrees from the x-axis, which makes it a 560 degree rotation. Negative 300 degrees, meaning we're going, starting south of the x-axis, we're going clockwise now. So not all the way around, but 60 degrees short of that, so probably around there. Like I said, it was 60 degrees short of all the way around, meaning that the rest of it would be that negative 300 degrees. All right. Real quick on letter B, I want to note that a good way to go about problems like that is by saying, hey, if I subtract 360, aka one full rotation, I had 200 degrees. I said that math, but I did not write it down, so I wanted to make sure I wrote that down as well. So, example 2, we're supposed to find coterminal angles, so angles that would start and end at the same spot for each of these angles, and we're supposed to do positive and negative. So how do you figure out a coterminal angle? Well, I'm going to use example B on number 1 as a reference for it. 560 degrees is coterminal with 200 degrees. 200 degrees would have looked like this in blue. let me try that again. It would have looked like this in blue. It would have gone just, the only difference to me would have been that it doesn't go around the whole rotation once and then go that extra 200 degrees. It just goes that initial 200 degrees. So those would be coterminal, for example. And then a negative coterminal one would look like this, or just like that. So it'd still start and end at the same spot, it just goes the opposite direction. So how you find it, essentially, is you just add or subtract 360 degrees. So to find a positive one, because it asks for both positive and negative coterminal angle, you take 60 plus 360, and you get 420 degrees. And so that creates a full rotation around it. And you could do it again to get 780 degrees, add 360 again, and keep going. A negative one would be taking 60 minus 360, so it'd be negative 300 degrees. And those, all three would end in the same exact spot. We need to try letter B on your own. So once again, we're going to be adding or subtracting 360. So if we add 360 to 215, we get 145 degrees as one coterminal angle, positive one. If we subtract 360, we get negative 575 degrees as the negative coterminal angle. So now, let's continue on. Degrees versus radians. So we're like I was saying, this is going to be a new one for us to learn that we can measure in radians. So a radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. Meaning, hey, you have a circle. From the center to any point on the circle is the radius, or as we call it, length r. So we have this angle generated by this right here, rotating from here to here. And the initial and the terminal side are both lengths r, because they're both the radius. Well, the radian is the angle measure of that. So it's the number of degrees for that. So in this case, it'd be right there would be a radian. Now, how you convert from degrees to radians or vice versa is 360, or so I guess some helpful tools are 360 is equal to 2 pi radians. And how you would go about that is by saying, hey, circumference of a circle, the distance around it, is 2 pi times a radius. And so, and a full circle around is 360 degrees. So half of that, 180 degrees, would be half of 2 pi radians, so it would just be 1 pi, or pi radians. So radians is not something that we're multiplying. Radians is just another unit, so similar to degrees. All right, so now we're going to learn about this thing called the unit circle. But before we get fully into the unit circle, sorry, we're not going to learn about the unit circle quite yet. That comes later in the chapter. But we're going to start with how we would get to the unit circle. So if you have a circumference with a circle, and the r is 1, the radius is 1, the circumference of that would be 2 pi. Because remember, circumference is equal to 2 pi r, as I just discussed, so you would plug in 1 for r. So the amount of radians in one circle is 2 pi. Now, if we had just a circle here, and it's just kind of drawn onto a normal x and y axis here, coordinate plane, if you will. As we were to rotate an angle around, let's talk about what our different angle measures are. So here we have some different ones highlighted. We have 30 degrees at this line, 45 degrees, 60 degrees. This is 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees. You might notice that the first and third lines each time go by 30s. So we're going 30, 60, 90, 120, 150, 180. And the middle lines each time are going by 45s. 45, 90, 135, 180. And that's going to continue the pattern all the way around. So I'd encourage you to go ahead and fill out the others. We'd end up getting 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and 0/360 degrees. Radians, we said that a full rotation would be 0, or the actual rotation would be 2 pi, meaning that halfway around would be pi. Well, half of pi, so up here, would be pi over 2. Halfway between pi and 2 pi would be 3 pi over 2. And we continue just kind of going in parts here. So if you go between 0 and pi over 2, and we're going halfway there, that'd be pi over 4. Because 2/4 from here to here and from here to here would make a half. And then this would be 3 pi over 4, because it's halfway between pi over 2 and pi. And this would be, 5 pi over 4, because halfway between pi and 3 pi over 2. And this is 7 pi over 4. Once again, halfway between 3 pi over 2 and 2 pi. And then filling in our other ones, if there's 1, 2, 3, 4, 5, 6 of these, and they're all 30 degrees apart, so they're all the same distance apart, between 0 and pi, that means pi is cut into 6. So pi over 6, 2 6 would be pi over 3, 3 6 would be pi over 2, 4 6 would be 2 pi over 3, and 5 pi over 6 would just be 5 6. And continuing it on by 6, we get 7 pi over 6, 4 thirds pi, or 4 pi over 3, 5 pi over 3, and 11 pi over 6. So that's just saying how far along it is compared to 2 pi or 0 for the pi and the radian there. Alright, so finding a positive and negative coterminal angle in radians, we're going to have pi here. So a hint, instead of adding or subtracting 360 degrees, a full rotation in degrees, we're going to add or subtract a full rotation in radian, which is 2 pi radian. So pi over 4, if we're adding or subtracting 2 pi, don't forget to get common denominators. So you'd have like pi over 4 plus 8 pi over 4, for example. That'd give you 9 pi over 4 for a positive 1. And subtracting 2 pi would be the same thing as pi over 4 minus 8 pi over 4. And then give you negative 7 pi over 4. Go ahead and do letter B on your own. So adding 2 pi, or 12 pi over 6, would be 7 pi over 6. Subtracting 2 pi, or negative 12 pi over 6, would be negative 17 pi over 6. Now, how to convert? So to convert degrees to radians, you multiply degrees by pi radians, or you can abbreviate it to rad if you want, over 180 degrees. And you go the other way around, radians to degrees, you multiply the radians by 180 degrees over pi radians. Just reciprocals of each other. So whatever one you want to get to, so if you want to go 2 degrees, the degrees will be on top. If you want to go 2 radians, the radians will be on top. So these four are doing radians 2 degrees, so we're going to multiply by 180 degrees over pi radians. So radians, we're no longer in that. Pi and pi reduce. 2 and 180 reduced to 1 and 90. So you're left with negative 90, and we are still in degrees, or we're now in degrees, I should say. Go and try the next few on your own, reducing as much as you can. So radian and radians, pi and pi reduce, 3 and 180 reduced to 60 and 1. So we're left with 7 times 60, 420 degrees. So that unit is now degrees. I'd try letter C and D on your own. Multiply by 180 degrees over pi radian. Pi and pi. There should be a little radian there that reduces as well. So that's how you know you're in degrees. And 4 and 180, 1 and 45 degrees. So you do 3 times 45 degrees and get 135 degrees. And last but not least, pi and pi. 5 and 180 is 36 and 1, not respectively. And negative 8 times 36 is negative 288 degrees. Now, sometimes you might still end up with fractions. That's okay. Or you might end up making it just some sort of decimal. Now we're going to go the other way around, degrees radians. And then finding a coterminal angle when we're done that has a radian measure between 0 and 2 pi. So making it between no rotations and 1 rotation. So negative 45 degrees, we're going to multiply that by pi radians over 180 degrees. So degrees and degrees, negative 45 and 180 becomes negative 1 and 4. So you end up getting negative pi over 4 radian. And we said we want a coterminal one that's between 0 and 2 pi. So we're going to add 2 pi to this one. So if we add 2 pi to this one, or 8 pi over 4, which is really 2 pi, we end up getting 7 pi radians. It's going to be 7 pi over 4 radians. The next one, negative 270 degrees, we're still going to multiply by 180 pi radians over 180 degrees. Degrees and degrees, 270 and 180 reduces to 2 and negative 3. So we get negative 3 pi over 2 radians. It's not between 0 and 2 pi, so we're going to add 4 pi over 2, aka 2 pi, and get pi over 2 radians. Negative 150 multiplied by pi radians over 180 degrees. Degrees, 150 and 180 reduced to negative 5 and 6. So we get negative 5 pi over 6 radian. It's not between 0 and 2 pi, so we're going to add 2 pi, aka 12 pi over 6. And we're going to get 7 pi over 6 radian. Last but not least, multiply by pi radians over 180 degrees. Radians, the zeros reduce, and 18 and 30 reduce to 3 and negative 5. So you get negative 5 pi over 3 radian, not between 0 and 2 pi. Add 2 pi, aka 6 pi over 3. And you get pi over 3 radians. That is it for section 2 today of Unit 8 in Algebra 2.